So tonight I thought that I would do something a little bit different by streaming what I'm working on. Um, I have this project where I'm using Elixir and the Nerves project to run pump communication with a Medtronic insulin pump, and I'm making pretty good progress. My goal is to have a few more things in place before the Elixir Conf talk that I'm giving this fall in September. And I thought it would be interesting to work on this more publicly. The thing that I'm working on right now is I have this firmware that runs, so it's an entire operating system with the Nerves firmware, and it has the pump communication happening. So every 5 minutes, I get continuous glucose information, and it gets pushed up to Night Scout. I'm actually wearing the continuous glucose monitor myself right now, and so this is what it looks like when it runs. You can see I'm kind of holding it up here. This is a Raspberry Pi Zero with wireless on it, and also has a special chip on top that talks to a Medtronic insulin pump. And right now, every 5 minutes, it just wakes the pump up and communicates with it and says, hey, what's the CGM look like? Continuous glucose monitor. And then it pushes that data up into Night Scout. And I didn't write anything about this Night Scout app. It's all a node server that's running on the internet. It's really just aggregating this data and putting it out there so you can understand what the data points look like and what they mean. This is the Medtronic pump that I'm wearing right now. I'm not going to show you the CGM. It's attached to my body, and that's a little bit embarrassing, so I'm not going to do that. But one of the problems that I'm having is when this tiny computer here boots up, the first thing it tries to do is connect to a wireless internet connection and then grab the local time. So it wants to get very precise time data via NTP. That all runs inside Nerves, inside the Elixir app. It goes and finds an NTP date and then sets the system time. If for some reason it is unable to set the system time, it kind of freaks out because it thinks that it's 1969. And then every 5 minutes, it goes and it says, hey, pump, give me the last 20 minutes of data, but it uses 20 minutes offset from the epic, which is not ideal. So it just fetches as many pages as it's willing to fetch, and eventually it gives up because it's in a different decade than we are. And what I'd like to do, and I know is possible, is that the insulin pump actually has a command that you can run to query from the pump itself what the date and time is that it thinks that it is. Generally speaking, it's probably better to be able to use NTP and use the internet to set the time on the computer, so that if there's anything off between the pump and what Night Scout thinks, that we can actually identify that. I don't want to get that sophisticated with it yet. I really just want to handle this situation where the pump is the authoritative time because there is no NTP server available to give us a time. And so I'm going to kind of dig into that problem space just a little bit and try to understand what it's going to take to query the pump and ask it what time of day it is. And I just saw the Sensi Elixir note, so I'm pretty anxious now. But that's fine. I'm going to keep moving. So overall architecture of this application is pretty simple. At the very lowest level, there's a UART, a serial connection to this chip right here. Let me just switch over to the desktop. So at the bare bones, what you're looking at is basically just a serial connection to this chip on top. And the Raspberry Pi Zero, when it boots into the Nerves firmware, just starts talking to this chip. And it happens to communicate at the same frequency as the insulin pump. So when it's all said and done, it knows how to communicate at 916 megahertz and wake the pump up and do all kinds of fancy things. Much more fancy than the get time and date thing I'm trying to do tonight. And so under the covers, the UART is essentially its own gen server. It handles the management of the state of that serial port and all the communication that goes across it. And then there's a couple of small layers in between, but at a higher level, there's a pump gen server. And that pump gen server has the responsibility of doing logical communication with the pump. So underneath the covers, there's like packet radio and all kinds of other stuff going on. But at a higher level, what's going on is we're getting a CGM page of data, which is a continuous glucose monitor page of data. That page is 1,024 bytes. It needs to be decoded. Elixir is great for that. But really all the pump is really responsible for is making sure that we fetch the data that we're looking for. We assemble all the packets in the right order. The CRC checks out, and we go on from there. So you can see really the only things that are supported right now are getting the current CGM page, which is just an integer. It's a moving integer. Every time that we wrap over to a new page of data, then that number increments by 1, and that's how we know which one to fetch. Read CGM page actually pulls in 1,024 bytes of data, reconstitutes that into meaningful information, and then gives us back an array, a list of data of CGM points of either sensor readings or other events that happened in the CGM history. Further down, there's a history page, which is more generic information about the pump. It's like really just generally speaking what's going on in the pump. If I calibrate my CGM, or if I set the date and time, change the battery, any one of those things that would happen gets written into the history so that you can debug and troubleshoot. So that's the history page. And ultimately, it really just supports those 4 things. And up until now, that's been good. But tonight, I want to add a different one. Sorry, I'm new to the Twitch thing, so I'm trying to dart back and forth between conversations that are happening and live streaming and coding. This is hard. I don't know how John Eglin does this. All right, so one of the awesome things that I get to use is a body of knowledge and reverse engineering that has happened before me. And so what I'm going to do first is go look at the Riley Link mini med code. And this is all Swift code. I just realized I'm not presenting it. So this is all Swift code that someone has written, mostly Pete and Nate, Pete Schwamm and Nate Ratcliffe. They were the ones who built the original Loop app for the iOS devices that are out there. Riley Link is also a hardware module that Pete built. And he actually wrote the firmware that I'm using on this other chip as well. It's a generic communication for packet radio. So people have done all kinds of work ahead of me in all of this. And really, I'm just kind of standing on their shoulders at the moment. But the different kinds of commands that you can send to the pump, I mean, there's a lot, way more than 4. You can kind of see there's quite a few here. And what I'm really looking for is to find out how to get the current date and time. It looks like there's one called read time, so I'm going to look at this one first. Nice. Okay, so if you're looking at this, you can kind of see how there's some like binary unpacking of these bits. You end up with what looks like 4 bytes. Nope, looks like maybe 8 bytes. And they're pulling off little pieces here and there. Some of the bits are used for random other stuff in between all the other bits that are actually date information. I'm not sure exactly why they decided to pack the data in these bits this way, but it's pretty well known at this point, so I'm not too concerned that we won't be able to get there. I am a little bit concerned about this potentially being a different date format than the rest of them. That could get a little interesting. So as I dig into the code here a little bit, I'm pretty familiar with this. I actually wrote the CGM implementation for the Swift side of things. So I've been around these files quite a bit, but I don't exactly remember where everything is. It's been a little while. In any event, this is the message types that you can send to the pump. And you can see there's a read time one. So byte 0x70 in hex is the read time command. So I'm kind of going to just play around a little bit here and see what happens. Inside here, the project is broken up in a number of different ways. And one of the things that how it's broken up is at this like logical session layer. And a logical session is basically communication that's ongoing with a pump. So in here, you'll see it's a little bit muddy, but there's one place where all the different commands are defined with all the different opcodes. I haven't really had a need yet to clean this up. I've sort of been deferring the refactoring of this, but I think I'm getting pretty close to the point where I need to do this. For the moment, though, I'm just going to pile on and add one more thing. I'm not doing any test driving or anything. I'm really just trying to spike right now. Everything that you do when you're communicating with these insulin pumps ends up encoding the pump serial number into the message itself, which also ends up going over the air basically unencrypted and barely encoded. So you can find out all the different serial numbers of all the different pumps that are out there in the room with you pretty easily. This is what the security researcher who found some of this stuff was pointing out as a problem, because you can then turn around and send commands to send insulin into people's bodies if you know their serial number in their pump. The newer pumps all have this disabled, which also disables the ability of the community to do looping on these things. So it looks like read time is, there's not a lot to it. I'm hoping this is pretty straightforward. I'm going to guess there are no params on this one. So I'm just going to add another GenServer call in here for read time. I don't know the convention here. When you have a single thing like this, is it still convention to put it inside a tuple even though there's no parameters like that? I've been running into some dissonance here with sort of some of these things taking parameters and other ones not. Like I could just as easily pattern match without it, and I'm not sure what the sort of going decision is in the community for that. So if you want to put that in the chat, that would be really helpful for me to sort of make a decision about that. I am going to, in a very non-embarrassed way, just copy that entirely. It's a spike. That's what I'm calling it. Although the code probably lives on forever, because that's how spikes work. All right, in this case, I don't believe that I actually need the model number. I'm going to guess that all the different models behave the same way and return the same data based on that call. So the first thing I do is ensure that the pump's awake, and that's just a command that goes and listens for other activity around the frequencies of the pump communication. If there's another pump or another loop talking right now, I don't want to step on their communication. So I both listen for some silence, and then I wait and then ask the pump that I'm really looking for whether it's awake. If it's not, I send this like crazy blast of data to it to wake it up. And you can kind of see that here. It calls power control, and it repeatedly executes the same command 500 times, which is like, hey, wake up, hey, wake up, hey, wake up, hey, wake up, hey. And then finally the pump just says, fine, whatever you want, I'll wake up. So it's kind of like getting my kids out of bed in the morning. So I'm going to create a command for this read time, or I'm going to call this command and execute it. And I'm just really curious about what I'm going to get here. So I don't really have a response. Like I'm not unwrapping that thing at all yet. So I'm just going to comment that out and then inspect what I've got at the end. And really the only state in here is the pump model number. That's important, but I can really get that if I let this pump gen server crash, then all I really need to start it back up is the pump serial number. It can turn right back around and say, hey, look, if I don't have enough information to know what model you are, and the model number is important for decoding certain parts of history, like the newer pumps have longer bytes in some of the command responses, and they have a little bit more precision in some of the answers that they give. So you have to know what pump model you're working with in order to decode the information correctly. But if I lose that data, I can always get it back just from the serial, and then I can wake the pump up and ask it what model number it is. So really this state stays the same for almost all the gen server calls. I'm not sure if the gen server is really the right way to go with this, but I'm kind of going with it for the moment. So let's just see what happens if we call read time on this thing. So inside my IEX console, I'm just going to alias a few things to make it easier. And the very next thing that I'm going to do is start a link with the serial driver. That'll give me the information that I need then to turn around and ask the chip itself, not the insulin pump, but the chip that I'm working with, what version of history do you have, or what version of the firmware do you have in order to talk to the pump and get history and things like that. Right now I'm running on 0.8 of this firmware that Pete wrote. 0.9 is out, so I'll eventually upgrade to it, but this just basically tells me I can talk to the chip. Next I'm going to set the base frequency to something close to what my pump is operating at. Different Medtronic pumps operate at different frequencies, and they're not tunable in any way, but the chip that we're using to talk to them is tunable. And so as a result of that, we can sort of call them up on their frequency, even though we know that they can't change theirs. So I'm going to go ahead and start up the pump gen server now. And we're just going to see what happens here. All right, so it's waiting for silence. It's going to give it 5 seconds, and if it doesn't hear anything else going on, then it's going to try to wake the pump up. So these timeouts mean, hey, your insulin pump is asleep. And now it's going to turn around and try to wake it up. Yep. That crosstalk means that there is another insulin pump in the room that somebody is talking to. And that's probably Amanda's upstairs. All right. So bad times. I thought that I didn't do the response to get data on this. Gonna try going a little bit lower level than the gen server here. All right, it looks like underneath me my UART crashed. So both of the gen servers on the top and on the bottom crashed. This is gonna be fun. All right, so the pump's not awake. I need to wake it up first. I'm just going to try executing a different command here on the pump level to get it woken up, because it's been a little while since I've gone that low level on it. Sure. So this is at a quite a bit higher level. This is the monitor for the blood glucose information. So this is the CGM loop, and it's able to take information from the pump gen server's response and parse it out and get meaningful data. So really what I'm asking it here right now is, can you give me the last 20 minutes of sensor values? So let's see what happens when we do this. All right, so it went, and you can kind of see some of the logging that happened here. It's pulling in, each one of these pieces of information is one packet, and 16 of those make up a 1024 byte page, and this is what a page looks like. It's basically just a bunch of events written sequentially, followed by a CRC at the end. Very rarely, but it does happen. It will actually go back and rewrite something in the history. I didn't actually know or believe that happened until recently, because I saw it happen to one of my sensor updates, but that's a little bit unsettling, because I thought I thought this was essentially immutable forward. So as long as you had it written in the history, it was going to stay there, but that turns out not to be the case. So that's exciting. So here I have 3 different sensor glucose values, or SGVs is what they're called. So my last 3 readings were 94, 92, 84, and 80. So that's good. We're talking to the pump. It's giving us good stuff back. I'm going to try to run this thing again. Wow. So it worked right away. It looks like I read the time, and I got back this data, and I have absolutely no idea what that is. So awesome. So here I can kind of parse out. I've gotten this sort of weird superhero ability to look at this data and see what it means without having to do a lot of decoding to it. That's both good and bad, because I feel like I could use that power some other way more usefully. But anyway, A7 is the hex for CareLink, which is the MiniMed protocol. So this is basically saying I'm MiniMed. I believe A7 stands for the pump communicating. And then after that, some serial number stuff. 70 is that command that we sent. And then there's stuff that comes back after that. And so somewhere encoded in this is the date and the time. And should be fun to try to pull this out. So I'm going to pull up this message reference again really quick and just kind of see what's going on with what other people have done, because it seems pretty gnarly. So the hour, looks like the hour is the 2nd byte. The minute is the 3rd. The second is the 4th. And then I'm not sure exactly what the range looks like in Swift. I can't remember that off the top of my head, but we've got a year, and then we've got month and day, which I think looks relatively similar to some of the other date time stuff. So I'm going to try to see if I can marry those two things up. So all of that belongs or lives in date decoder. I better just make that full. I tried to be pretty proactive on my documentation of this thing, since those bits are really strange. Some of these flag columns or bits are used for various completely unrelated things. Like if a command happens to have a timestamp, but also some other things involved with it. Sometimes they'll just throw stuff into these flags related to the command and not at all to the date. I'm imagining that's probably run-of-the-mill when you're trying to pack everything in really tight, but it's weird that they happen in the middle of these bytes instead of at the end or somewhere else. All right, so right now I have decode timestamp, which is a little bit of a misnomer at this point. This is decode glucose timestamp. So this is the CGM history table and what they look like. And then further down, there's a decode history timestamp, and this is really the history page format. And I'm wondering and kind of hoping that maybe this is the same thing. But these things only take up 4 bytes, so I'm pretty sure I'm making a new thing here. And I'll just call this full time. All right, so going back to the other part of this, if I assume that I'm pulling in the bytes of this message in order, then the first byte is going to be hour. I'm not using any shorthand or anything for that, and I'm thinking there's probably a more efficient way to define exactly what this is. Maybe we'll just do 8. So it goes hour, minute, second. And then it goes year, where year looks to be 2 bytes. Look, 4 and 5. And then month and day. I'm just going to turn this into a naive date time right away. All right, so what I have left here, hopefully, is 2, 3, 4, 5, 7. Was that 7 or 8 bytes? 7. Weird. Okay. So I have this, in the code I have a means by which I can take the response from a command and do something with it. And that's in the response portion of this. So the command assembles the command to be sent to the pump. The response parses the response after it comes back. I'm really unhappy about how both of these things are just getting overwhelmed with repetitive junk, but I'm also sort of of the opinion that I want to forge ahead and make progress on this. So that's a competing tension that happens a lot during the day for me too. It's hard for me to determine exactly the right time to do refactoring. I think I've put this one off maybe a little bit too long, but I'm still okay with that for the moment. And so what I'm going to do here is call this date decoder method. All right. We'll just see what happens here. All right. Okay, the pump's asleep. I'll go ahead and show you what the pump looks like, despite the fact that when it's sleeping and when it's awake, there's no difference in what it looks like. All right, so it woke the pump up, ran the command, got the data back, and something else was wrong. Opcode 112. Okay, that's my get time command. So here's my data, and it's basically saying, yeah, you get all the bytes back. The bytes are, for most responses, there's 64 bytes of data, regardless of whether or not it actually uses those things, just to keep the packets similar, I guess, or something like that. So what I'm seeing here is 1, 2, 3, 4, 5, 6, 7, and then a whole bunch of nothing. Which means in my, either in my date decoding or here in the pump, I need to handle not passing all of that stuff in. And I think this is the right place to do it. So I just have to think about how I want this to work. I'm also not entirely sure what I can do with width yet. So this should be interesting as well. I think I can pattern match here. Find out soon enough, I guess. And I've been modifying the wrong function. That's a little bit better. All right, let's see what Elixir has to say about this. Yeah, I kind of wondered about that. I don't remember the syntax for parsing it back out and keeping it binary. I might have to go and code dive a little bit here. Binary size. Okay. Not byte size. That's more like candy bars and stuff. All right, try it again. All right, we're back up. Let's see what happens. Are you still streaming me on that screen over there at Gaslight? Well, that error message is worse than unhelpful. That's what I get for copying and pasting so publicly and unashamedly. All right. So I got a response back that looks pretty okay. And that makes me wonder what happened. And I'm wondering if I'm off by one here. All right. I'm just going to try to call this directly on the date decoder. All right, invalid. Okay, so if I take this first byte off and add the last one on, still invalid. Fine. Puts driven development it is. 7:21. That doesn't seem right at all. That doesn't look like the time on this pump. Yeah, it says it's 9:14. So that's wrong. Let's try the other one. That looks basically the same. What did I do? Did I just type the same thing in? Oh. Yeah. I see. Didn't actually assign that or do any matching on the new stuff. So let's try this again. Hey, look at that. August 1st, 21/11/15, and the year 4017. So that's off. I guess when you have 7 bytes to play with, you don't have to play games with how many offset years you have. All right, that's a good deal. I'm not sure why I'm just wrapping this thing in a... Okay, I'll have to come back and look at that later. So now if I go back into the response, this is actually the place where I should have done that binary decoding. So the first byte means something, but I don't know what it is. And then the next 7 bytes after that are the date. I'll call it the packed date. I don't know, that seems silly, but 7 bytes of that, and then the rest we don't care about. I'll call it encoded. I think that sounds a little bit more like what's going on here. Ha. Accidentally killed my editor and then just found out that the thing that helps me launch it isn't installed on the version of Ruby I have right now. That's fine. Okay. And we're back. Trying to make sure that my font size is okay here. Let me go one more. Okay. So going back into my pump gen server where I was doing this kind of wacky decoding thing, I'm going to stop doing that. That doesn't seem like the right thing. And I feel like I'm getting pretty close here. So I'm going to go ahead and put the parse date in the response. We'll see what happens here. I guess I didn't kill it. I just made it angry. Here we go. Wake up the pump. And then we're going to call read time. Another copy and paste here. I think what gets passed in here is actually the command opcode as well, but it still doesn't seem to be working. Oh, it wants a full response object. Okay. Try it again. All right, here we go. Oh, it's found another pump communicating. Okay. So it matched the response. That's good. Now I get this invalidate thing. I wish I could tell exactly what it is that it's passing in. I'm not sure why that's happening. So good things. 1, 2, 3, 4, 5, 6, 7. Now I'm off by 1 again. Sure. All right, I got my date back. Finally. So when I call read time, I get 2017, August 1st at 9:24:07. This is an Eastern Daylight. So, yep, you can kind of see here. That's my date. So, I think I'm probably going to stop the stream now. The next thing that I'm going to do is actually pull this code into the Nerves firmware and do the work of trying to figure out exactly how to set the system date and time using a number that I know, using a date that I actually have here. So I've been able to pull it from the pump, and now I'm going to try to get the system to use it. But I'm kind of getting tired of streaming, so I'm going to call it. Thanks for joining with me.